Ready?
Yeah.
All right, Hunter, we went back and we added centimeters per second over our average velocity that we calculated between 1 and 6 seconds. Now we're getting right here to the amazing point where we can find the slope, which is the velocity, at exactly this point. I picked this point, 5 minutes. All right. We are going to find the slope at this point. The slope of a line is everywhere the same when it's a straight line. So I'm going to pick this point and this point to use my slope formula with. So Emily, what is this one? Was it 2, 2? Mm-hmm. And this, was it at 0, 0 in the beginning? Yeah. Okay. All right. My board sketch might not match, so that's why I keep checking. So do a slope formula with these 2 points and tell me what you get. Not a very hard calculation. Zach, when you've gotten it, what is the velocity or the slope?
Just 2.
2, right. So you have
1
2 minus 0 over
2 minus 2.
over 2 minus 0.
Just be
So,
1.
which is, oh, it's not 2. What is
No,
it?
1.
1. Right. So we have 2 over 2, which is 1. And that will be 1 centimeter per second. We can actually find an instantaneous velocity anywhere on this slope. We can even find one where, let's try over here if you would, right there at time equals 8. See if I have one of those that I can do. So what you're going to do is find time equals 8, go straight up from the 8 to the graph and establish the point where you want to find the slope. Then you're going to draw a straight line at that point that touches the graph at one point, or if it's right on the graph, that's fine, but it has to be a straight line that is tangent to this graph. So does that graph fairly straight at that point?
Yeah.
All right, now everyone's going to draw a different triangle, but amazingly, in mathematics, you're going to get the same slope. So from that straight line at time equals 8, I want you to establish a triangle. Your triangle is going to be different from the next guy's triangle, but you're going to establish a triangle to get the rise over run. Or here mine looks like, and it's going to be different, it looks like mine is about 2 seconds long on this side and about 3 on the centimeter side. And that is totally going to be different from yours because I'm working on the board with an inexact graph. But do you see where I'm getting these numbers? This side is coming from the scale below it, so I'm seeing about 2 seconds there, and this side is coming from this axis where I'm seeing 3, maybe 3.5. You don't have to have whole numbers. And again, we're going to be, when I correct your work for slope, you're going to have variation. So mine rise over run came out to 1.5 centimeters per second. And what was yours? Do you have a value there for your slopes at time equals 8? What do you got coming? You got 2? Anyone else get around 2?
I got,
2?
wait, that's the slope?
Pardon?
For the right side?
We're over here now. So you have to
Well,
form a triangle and
really?
get the rise from over here somewhere on your chart. Figure out how many units your rise was and how many units your run
Wouldn't the
was.
slope be like -2 then?
Oh yes, no, I was just going to get to that. Good point, yeah. Pardon? All right, 2. Very good. All right, so we're getting answers around 2. Mine's on the board. It came to 1.5. And so the thing that we have to recall about slope is when it goes this way, it's negative. And when it goes this way, it's positive. And you can tell if you don't want to memorize the negative slopes from the positive slopes. To get from this point to this point, you went down, which is negative, and then to the right, which is positive. So you have a negative divided by a positive. So that's another way, some way. So this slope was correct, it was positive. This one is negative slopes. All right, that's about our, I want to take this information and do another one of these tomorrow. I think the graph, is it on the back of your paper? No? All right, well, I have another paper to hand you with another graph. And that's my bell for the end of class. I don't know if it matches the schools. So I want you to try some Oyos that will practice this and see how you do. The Oyos that I want you to do, you can write this in on your little homework spot, are 1.4, 1.5, and 1.6. They will exercise the slope information.
1.4, 1.5, 1.6.
1.4, 1.5, and 1.6. This is a nice curriculum. They don't pile you up with a lot of problems, but they are meaningful problems. And if you can get those three, then it shows me you understand the information. You can put those right on your notes. In fact, actually, I think it's a graph. Let me hand you this. I think what I tried to do is put the Oyo. The Oyo, I think, looks like this. It's on the back of this handout. So you can actually draw on it. You put your triangle and so forth. And it can write down your work here for 1.4, 1.5, and 1.6.
Should I stop the recording?
Bye, Hunter. Hope you're feeling better. All right, can you show her this paper?
You're missing Emma's birthday, by the way.
So yeah, this is
Yeah,
what's
it's
gonna be
Emily's.
like the homework we're gonna get. Yeah.
So just show her 1 point. Is it on the view?
Yep.
Okay.
Okay.
Okay. Bye. I'll
Bye.
send it with her mom.